In this example, we will use a match pairs T procedure on our TI84. Let's go ahead and read the problem. Blastobike, a bicycle manufacturer, claims their bike will increase speed and hence reduce route times for cyclists. A simple random sample of 5 competitive cyclists were asked to record their times on the same route while first riding a standard racing bicycle and then riding the Blastobike. The population of cyclists is assumed to be normally distributed, and the times are then recorded below. So here we have paired data because for each cyclist, 1, 2, 3, 4, and 5, we have 2 measurements, a repeated measurement that is paired on cyclist. So basically, we have dependent pairs. For the first cyclist, we can see that when they rode the standard bicycle, their time on the route was 29.1 minutes. On the Blastobike, it was 28.3 minutes. So our first step is to take the differences between these pairs. We can do this easily using our TI84. We could also do it by hand. However, let's go ahead and do it using our TI84 to save some time. So the first step is to put the standard bicycle route times in list 1. So I have 29.1, 33.2, 31.3, and so on. So I have the standard bicycle route times for all of the cyclists 1 through 5. Then in list 2, I will enter in all the times for cyclists 1 through 5 from the Blastobike. So for cyclist 1, this was 28.3 minutes, then 31.8 minutes for cyclist 2, and so on. My next step is to go to L3, where I scroll over to L3, and then I want to go up so I'm in this area of the calculator, and I'm going to subtract L2 from L1. So L1 minus L2, and I can choose my lists by pressing the second button or the second key and then choosing L1 and L2 and then pressing enter. Here I will get the differences between each observation or each pair. This really saved me some time. Now I can simply take the differences and use one sample procedures. So now I have to remember what list I'm in, L3, and then we'll go to Stat, scroll over to Tests, we'll do a T interval, so press Enter. We have a list of data. Our list of data is in L3 because that's where we had our differences, so second L3. Then scroll down, ignore the frequency, and we have to choose our confidence level. We did a 95% confidence level, that's what we want, and we press Calculate. And sure enough, we get a confidence interval from 0.623 to 3.89. Well, what does this mean? This means the 95% confidence interval estimates the Blastobike is faster on average by 0.62 minutes to 3.90 minutes. Why can I put faster here? Well, if I think about the context of the problem, I know that if my difference is 0.62, or my average difference is 0.62 to 3.9, and that is a positive value, what that means is that the difference between the standard bicycle times and Blastobike times, the average of that should be between these two. If it's positive, that means that the Blastobike was actually faster than the standard racing bicycle. Be sure that you can kind of understand how to interpret these types of problems. It takes a little bit of practice.